What if I told you your Rust app could deploy itself? Stick around, I will show you how. Welcome to Integration Ninjas, where we make complex deployments feel like a breeze. Today we are diving into deploying a Rust application on AWS EC2 using GitHub Actions because let's be honest, manual deployments are so last decade. Now, why Rust? Well, imagine a programming language that's blazing fast, never crashes, well, almost never, and make sure you don't accidentally break everything in production. That's Rust. It's like the reliable friend who always double checks your work and still runs at lightning speed. Here's the game plan. Dockerize our Rust application because containers is equal to easy deployment. Push the image to Docker Hub so it's stored safely. Set up a GitHub runner on AWS EC2 or personal deployment assistant. Automate everything with GitHub Actions because we love hands-free magic. Sounds exciting? Let's jump in and make this deployment seamless. To make this happen, we need to have our Rust application on the GitHub repository. We need to create Docker file and a GitHub workflow file. A workflow file will contain build job and deploy job, two jobs. Build job will build the Docker image and then it will push the image to Docker Hub. Deploy job triggers just after the build job. So in Docker job, we will have a configured EC2 runner, self-hosted runner, which will pull the image from Docker Hub and then it will run the Docker image as a container on EC2. Now let's move to hands-on. We have a simple REST application where we have simple CRUD APIs of users, like where we are creating the users and getting the user details and updating user, deleting users. And all these details we are going to store in the MongoDB database. So it's going to be a cloud database so that we are going to manage on the MongoDB. Okay, so we will create that and then we will write a Docker file for this application and then we are going to write a workflow file and then definitely we are going to deploy it to AWS EC2. So let's go to the MongoDB. Once you go to MongoDB, you have to click on create a new project in your account. So you can just name it as Rust app or any other name as you like. You can simply click on next and you can select the roles and other things, but you can create a project here. Okay, so let's start creating a cluster. It will take a couple of minutes, so we can create and we can just continue writing our Docker file. We can select a free version for this tutorial. I don't need much space, so 500 MB is like more than enough for me for the test purpose. Feel free to choose any other plan based on your requirement. So just name a cluster, any cluster. I will name it as dev cluster for the testing, and you just create deployment, so it will start deploying the cluster to the MongoDB environment. So we can just see here we need to create a database user actually, and we can create this and choose a connection method. So connection method will be through the drivers or any other one. So let's click on Rust suppose, or let it be. We can just click on done here. So let's wait for this deployment. Till the time being, we'll go to our application. Let's create a new branch where we are going to work, deploy to EC2. Okay, let's go to the editor, Visual Studio Code, and here I will pull the changes. It's already up to date, and here I'm going to check out my new branch. Okay, so this is perfectly fine here. I will just verify my branch here. It's correct only. Anyways, so in this project actually for environment variables, I would highly recommend suggesting that you store your secret details in AWS Secrets Manager or any other vault if you have. But for the time being, like I have just .env where I have stored my credentials, so that I'm going to create a workflow file and I'm going to pass those as an environment variable. So that's what I'm going to do in this tutorial. Okay, so let's see how we are going to do this. Let me create a Docker file here. Docker file is there already. Let me delete it actually and create a Docker file. It was a And here what we are going to do here, we are going to create a multi-stage Docker file that builds and run a Rust application efficiently. Like, see what we are going to do. So first of all, like, we need a base image. So base image, we are going to select Rust, and we are going to select 1.84.1, and probably we can see like what are the available options. So we are going to use this image bullseye as builder. Okay, and then what we are going to do, we are going to create a work directory, and we are name it as /app. Okay, so it sets the working directory inside the container to /app. Okay, now what we are going to do, we are going to copy only the cargo.toml file. Okay, so let's copy that, and here we have cargo.uml file, and both the files we are going to copy, cargo.uml and cargo.log, to the destination directory, which is the current directory. Okay, so like we are doing this before copying the source code to leverage Docker's layer caching, so it avoids like rebuilding the dependency if they have not changed. And once we did that, then we are going to copy the source code. So our source code is in the src folder actually, and that we are going to the container. Okay, so let's move it to the container. All right, now we are going to pre-download all the dependency without compiling them, and which will help speed up the build by caching the dependency. So for this, we are going to type run cargo fetch, so it will do that process. Okay, and once we did that, then we are going to run cargo build hyphen release. Okay, so it compiles the Rust application in release mode, so like which is more suitable for the performance perspective. So whatever the binary is getting generated, it will be in the app target and then release and then the respective Rust app. Okay, now it will be the next stage actually, so we can name it as stage 1, and it will be the stage 2, where we are going to like minimize the image for running the application. Like whatever the image we have now, it will be larger in the size. Now we are going to reduce the size of this image. So for this, we are going to use a minimal Debian image. So we are going to use Debian. Let's see the options available. Bullseye. Okay, we have, and we can use Bullseye Slim, as I remember. Yes, and now again we have to define the work directory here, so it will set the work directory here to the app. Okay, now what we are going to do, we let's copy hyphen from builder. Like it will copy the compiled Rust binary from the builder stage to the final container. Okay, so for this, builder and then /app target and release and then the Rust app. This is the path, so it will be in the Rust app. All right, So in the builder directory we have this path, and we are setting this into the container with this in the app folder. Okay, so it will avoid the unnecessary Rust toolchain files in the final chain. It will be the minimal image. Okay, now we are going to expose the port, let's say 5050. Like in my application I have exposed the port as 5050, so I'm gonna use that, and then I'm going to run the Rust application from this this location, sorry. All right, so that's all the final image. Now I would definitely like to go to my this one. So the cluster is ready. Now what we have to do, we have to set up a database actually. So this is like the connect, we can connect it here. Let's simply click on Atlas and see, this is the string that we have to use here. Okay, so let's see in our application where we are using this. In the DB we have one file, connection.rs. so we have this format mongodb srv, and then the username, and then the password. I have just left the space here, so those we are grabbing from this environment variables, and then this retry is true, retry writes is equal to true, and majority app name is equal to dev cluster. Okay, so I have updated this. So rest of the things we can just update it here in the .env, but we are going to do it on the runtime, so we don't need to like expose all these details, right? So let's go to the, now we have to create a GitHub workflow file actually. So for that, let's create, if we see this, like it's already there, but let's remove this and just I already deleted this particular part, move to trash, and inside .github we are going to create another folder, workflows, and then we will have a cicd.yml file here, right? And this cicd file we are going to name it as like deploy the Rust application, and when it will be triggered, it will be triggered on the push event, right? Definitely on the push event we are going to trigger, and on which branch, so that also we need to define here. It should be on the deploy to EC2, right? So required properties missing. Yeah, this is like we have to like define many things here. Now we have to define jobs here, like the GitHub jobs. So we'll have couple of jobs, as we have seen in the workflow diagram, that we will have couple of jobs. One will be the build one, first will be the build one definitely. So build job should be triggered on, it will be running on the machine of, I'm just gonna use GitHub machine, GitHub hosted runner instead of self-hosted we are going to use in the deploy phase, right? So here it will be running on Ubuntu latest, right? And now we are going to write multiple steps what we are going to do as part of this, right? So here let's name first action as check out the source code. For this we have one action uh, which we are going to use like this, actions slash checkout at the rate v4. So this is GitHub provided action which will check out the code in the server, and Now the next step is to log into the Docker Hub, log into Docker Hub. So for that we are going to run a command actually, docker login -u, then the username and -p, then the password, right? So how we are going to set this username and the password, right? So the username we are going to add like this, secrets. So these will be part of GitHub secrets, GitHub repository secrets. So like this we will add docker underscore username, and similarly here docker underscore password, right? Then what we are going to do in the next step, so before that, how we are going to store this information. GitHub repository secrets are the secret informations that we don't want to like expose the details to the outside world, so we will store it as a secret variable, so it will not be visible in the command line that run that the jobs will not be able to see these values. So I have already added this, so you can go to settings and you go to secrets and variables, just go to actions, and here you will find the repository secrets. So I have already added docker username and docker password, and you can also add the same thing. The next step is to build the docker image, right? So for this we have to run a command, docker build -t, and you can just write your docker repository, docker hub. You have to log in to the docker hub actually before that, and you have to create a repository here. So let's see, you can simply create a repository, you can write any name, the Rust app. I have already created a repository, so I'm not gonna create a new one. So you have to add username and your the repository details here. Okay, so what I'm gonna do is integration ninja slash rust app. It will be the my image name actually, so I'm gonna build like this from the current directory. And the next step is that I'm gonna push this image to the docker hub, push image to docker hub. Okay, so for this what we okay, there's a mistake actually. Okay, so we have to run, just type the command docker push and the image name, and we have to tag our image. So I'm just gonna tag it as latest one. You can just use GitHub SHA also, like commit ID, so that also you can use if you want for uniqueness. For this tutorial I'm just gonna stick to the latest one. So this is one of my job actually, so I need another job. So this will just build my uh, Rust application and will create an image out of it and will push it to Docker Hub. And again we are going to use the same thing on the AWS, the same image. There we will deploy this. We are gonna start it as a Docker container. So we'll have deploy job which will run on before that this needs to be triggered right after this build job. So we have to add this needs keyword and we have to provide the information needs build. Okay, and we need to provide the information when it should run, where it should run. It should be on the AWS EC2 instance. So I'm just gonna write this details, runs on self-hosted. Okay, now we have to write the steps, but before that I want to configure my AWS EC2 instance also, right? So let's go to the AWS EC2. We are gonna create a new EC2 instance from here, right? We can create it, it's not a big deal. We have to create a launch instance. You can name the instance like Rust app, and you have to select the Ubuntu machine here. You can select the Ubuntu machine image and just simply create the launch instance. Before that you have to create a new pair. If you have already, you can select that. Okay, so I'm just gonna use it as it is without any key value pair, but it's not recommended, so you need it to log into the AWS console. You definitely need to create that. So it's already like successfully initiated the launch of the instance. We can track the progress here. So it's just initializing. Okay, now we can see the state is running, actually instance state. And now if we click here instance, and then we can simply click on connect actually, and let's connect. It will allow us to like run the commands in the browser itself. It's opening a new terminal. Actually you can definitely open a putty and you can just use the same process if you want. You can like SSH there and you can log into the AWS console. So for this I'm just gonna use this command to run the not run, like actually I want to install the Docker in this machine, so it's nothing. So I'm just gonna update this and I'm gonna install the Docker and just gonna give the permissions. That's it. I just summarized it in one command. I will definitely share this in the video description. So once this will be completed, what we have to do, we have to go to our settings and actions and click on runners, and you have to click on one new self-hosted runner. And you can, since the machine I have created, it's a Ubuntu one, so I'm gonna use the Linux one, and we have to just follow the steps. Okay, so let's go here I can just verify the Docker version. So we can see the Docker is successfully installed here. So the next step is to uh, download the GitHub action and start it. Okay, so let's do this and let's run all these commands. Download the latest runner package here. And we have to extract this package, and after that we have to configure this. Okay, so here enter the name of the runner. So I'm just pressing enter for the default group. Okay, the name of the runner, you can name any runner here, rest app, and you have to add additional label if you want, otherwise you can skip it. And we can see the runner is successfully added. And enter the name of the work folder where it will like process their workflow files, like some of the like key files that GitHub Actions generally do, like where it will in the work folder, it actually clones that file and runs the scan. So let's enter, and the next step is just to run this uh, command /run.sh. It will start the GitHub runner. So this is the steps you configure the AWS. You have successfully configured a self-hosted runner on AWS EC2 machine. And while coming here on the runner section, we can see our runner is green and it's idle. It's listening for the jobs here. So these are the simple steps. So now like this will be like here, like I have to exit this. If you want, you can simply search like run GitHub Actions as a service. So you will find that document, so you can configure that so it will be running in the background. So you have to follow this couple of steps, you will be able to do that. Okay, so for this, for the timing it's fine now. Okay, since we are here, we can do one more thing. We have to add some secret details for our application, so that we can add, right? So in the secrets we have MongoDB, Mongo host, Mongo password, and the Mongo user. So let's add all this. Mongo user is same, password, host, let's add all these details. actually. Yeah, so let's close it. Let's mark it as done. We can go to the database section here, and we can go to the network access here, and we can just allow the access from anywhere. So from the anywhere we can just access this database, and I need to create a user actually, which I can use for test purpose actually. Add a new database user. Authentication method is password, right? So let's auto generate username. I can add integration ninjas 1, let it be. And I'm definitely gonna use this password and want to save this here in the Mongo password field. So this is my password. So for that I need to use my secret details here. Alright, so Mongo password we have just updated now, and let's add this user. Username is already exists, so we'll just create a new one here, integration ninjas 1, and let's add this user. You must choose at least one role or privilege. Okay, so we haven't selected any role. We can select Atlas admin and click on add user. So let's give never, and we can just update these details here as well. Update secret, so we have added it here. Now what else we have to update? We have to update the host and the DB. So those details we can just get it from a previous page actually. Simply let's go to Rust app, and let's click on this connect, and let's get all the other details. So this is our host name actually, so that we can update here. Update secret, and another thing is MongoDB database name, so that we haven't created yet, so that we can create. Okay, let's browse the collection details. Okay, so we can create a database. What we have created actually, let's see here. Database. Okay, so this is the DB name actually, so we can just create a test DB or anything, so that we can create. Collection name we haven't added. Test, let's add its test. Okay, so let's add the test details here. Now what we have to do, let's go back to our CI/CD file actually, and what we are gonna do here, we have to write the steps, right? So what are the steps here we have to perform? So we log in into the AWS correctly with our self-hosted machine, so we have access to our machine and we have installed the Docker there, right? Now the next step is to pull image from Docker Hub. All right, so for this we are gonna just use this command docker pull and this image name. All right, and then we have to use another command which can be like run the Docker container. Okay, so Here what we have to write is docker run and then -d and -p. It should be the port details that we have exposed, so it will be listening on this particular port. So one important thing we have missed is updating the AWS security groups, so let's do it right away. So we have this AWS security groups, so we have to edit the inbound rules here, and you have to add a rule. So you can just select port range to 5050 and you can just select network access and you can just click on save. That's it. Now you come back, and what exactly we have to do, we have to name the image, the name of the container, rust app container. So let's say rust app container, and then what we have to do, we have to just provide the environment variable details, right? So let's add it one by one. Mongo user and this details. So this is gonna be Mongo user for sure, and then let's say, but I'm just suspecting like this is like a less secure way, but for this tutorial this is like fair enough. So definitely I would like to recommend this to access all these details from the AWS secrets manager, so you don't need to provide any other additional details here. So that's the recommended way. And let's say add Mongo password, and I wanna add some additional details, which is Mongo host, and I think one more is, which is one more is missing. Let's see what it was in the GitHub secrets. MongoDB. Yeah. Okay. So I think, yeah, that would be better that if we provide this in the COTS format, so that would be good, I guess. So let's see first. Mongo user password. So yeah, so let's provide this in the COTS. It should be like this, not like this, equals to this value, and then this one, yes. So let's update everything. Actually it's a wrong format I have used, and yeah, the last one. Okay, so this is the steps that we need to perform. Okay, so this will definitely deploy our application, but let's say like if container already exists, we'll definitely see one error actually. So let's say we can just delete the old container if exist. Okay, so this is just for precautions. It should be what we can write, docker rm-f and the name of the container, just app container. All right, so that's it. So wanna try this out, so we can just commit. If there is any error, just definitely we are going to see like how we can rectify those errors. I'm just gonna commit these details, deploy to EC2, Okay, I haven't added the commit, and then let's push this. Okay, anyways, I'm just gonna do it. Okay, so we have successfully triggered a commit actually, and we wanna monitor this. We can see we have a couple of jobs, so build and deploy. So deploy will be triggered once this build job is successful. So this is failed itself. Okay, Docker login requires this thing, options. Okay, so there is one issue here. We have not used dollar actually, so that's a mistake actually from my end. Actually nowhere we have used the dollar, so that we have to use like while accessing these secret variables. Okay, it's a good learning. All right. So wherever we have used the secrets, we have to use this dollar, 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 and dollar. Okay, let's commit again. Okay, wanna see it again. Let's see this time if there is any new error or it proceeds without any issue. So Rust application generally takes like some time in building the image, like almost 2-3 minutes it takes. Till the time it happens, we can wait for some time, and we can see the AWS EC2 instance. Everything is working fine here. So if we see the build progress, it will take almost 2 to 3 minutes. Generally, Rust applications are always slow at the compilation, but these are like generally very fast in the processing things. But the compilation time is generally very slow. Not very slow, but it's generally slow. And this is our MongoDB database here. So we can just wait here, since it's gonna take some time here, like it took almost 55 seconds. I hope there will not be any error in the further steps, otherwise it will take again the same time actually. In the meantime, we can see the database details. So the database actions and the network access, you have to definitely like control by yourself, like who can access this database. You have to provide the proper roles and the permissions to that particular user. And the network tab also definitely you want to see, like if you want access to everywhere, so then you can just allow this port range, or you have to add the specific IP address also. If you want some for specific use cases, then you can add this IP address there. Okay, all right, it's took 1 minute 48 seconds. Now I think it should not take that much time. So let's wait for this to be completed. Okay, still we see the compiling stage is in progress. Took almost 2 minutes 26 seconds. Yeah, so we can see it's done almost, and it's pushing the image to Docker Hub. Okay, so we can verify also if this is pushed to the Docker Hub. So the last push was 3 days ago, and we can see it's just pushed less than a minute ago. Okay, so the next job has been failed, and okay, it's requires at least one argument. So I think we have provided some incorrect details actually here. So we can see here what is missing exactly. Okay, Rust app container, and the Mongo user we have provided, and Mongo password we have provided, to Mongo host we have provided, and this is the MongoDB we have also provided. Okay, the important thing we missed is we have not provided the image name. Slash Rust app. Okay, so this is the missing part here in this. So for this, for the time saving, if you want, I can just remove this step and we can just proceed further, and we can see, or we can just continue also. Let's see, git add dot git commit. So okay, definitely, like, I want to save the time, so I can do is I can just comment out this. Okay, let it be like let me just remove all this. And we can just comment this as well. So we can just commit it again, and we will just run this deploy job only. We have commented out rest of the things, so let's see if this deploy job is succeeded now. Since we have already tried this, so we can just, I will just comment this out, so we can see this application is deployed now. So let's try accessing our application from the AWS. Okay, so let's go to the AWS instance, and here we click on the instance. So this is the public IP4 address here, and here we have exposed the port as 5050. So okay, we are not able to find our application here. Our application is not accessible on AWS. Okay, pull is completed, but delete. Okay, that was fairly there. So what we can do, we can create a new tab basically, and we can just see the running processes, docker ps, right? About a minute ago, and we can see it's listening to 5050. So this is the public IP4 address 5050, and we have to provide users. Yeah, so we can see we can hit our endpoint easily. Now what I have to do is I have to just like add one user and see like if everything is working fine. Let's see John Doe, and okay, we can see this is already added, and once we refresh this, we can see this user has been available. Now wanna see if I'm adding a new user, integration ninjas. I will be see that as well. Definitely I'm gonna add my email here. So let's see, yeah, this also we will see it's added here. So we can see all these details has been added. So we have another APIs like edit and delete, so feel free to try those APIs as well. There will be no big challenge. The only thing is like I just commented out this part here. Now I will just again revert this and will commit all these details so it will be accessible properly. So the deploy is wrong, deploy to EC2. So the spelling is wrong, so pardon me for that, but it does your purpose. So the next build will be triggered, the deploy and another one, so it will does the same process and will deploy the application. So this is the complete process. And now like it's very simple, it's a Rust application. Now it will be deploying itself, no manual work, no stress, and just automation. Quick recap of what we did today: we have containerized our Rust application with Docker, pushed the image to Docker Hub, set up a GitHub runner on AWS, automated the deployment using GitHub Actions, AWS deployment using this GitHub Actions. We have configured the AWS EC2 as well. And now every time when you push an update, suppose like this time I just configured it for the particular branch EC2. Now you can set up for different branches, or suppose like when the main code is like merged to main branch, the code is merged to main branch, then you can just trigger this pipeline. So everything it can be automated now, so it will save your time, and definitely it will like improve the productivity, improve the development time as well. If this saved your time and sanity, hit the like button, share it with your developer friends, and subscribe for more automation goodness. Got questions? Drop them in the comments, I will answer them all. Yeah, all right, that's a wrap. Happy coding and see you in the next one. Bye.